Well, hello and welcome. Welcome to a second grade lesson in Module 4. This is number 5. Lesson number 5, and lesson number 5 it presents a number of story problems for you to solve. And the story problems, they challenge you to think about what makes sense and what kind of operation you'll choose. And the word operation means, are you going to add or are you going to subtract? Those are the two operations that you use so far. These two diagrams, these two drawings can help you to understand, should I add or should I subtract, right? And you've been using these for some time now. I know that they were introduced to you if you attended kindergarten or first grade math. They were introduced. And this whole idea of a number bond is for you to understand that if we have a total amount of something, that total can be broken apart. And it can be broken apart in 2 parts or 3 parts or 4 parts. But no matter what, when you put these parts together, they add up to the total. And so our brain, if our brain recognizes that part plus a part equals the total, that can be really helpful. Because in a story problem, if we know the 2 parts, then we'll know we need to add to find the total. And if we fill this in and realize, oh, there's a missing part, then we know that we could take the total and subtract a part and find the other part. And that's a pretty important thing to realize, and it's a wonderful thing to realize because it can help us understand how we might go about solving a problem. Same is true with the tape diagram. It's just another way to look at it. And the tape diagram, if we know the 2 parts, then our diagram might be like this. There's a part, there's a part. What are we missing? The total, right? On the other hand, sometimes we know the big number, we know the total, the whole number, and the other part, and we know one part. In that case, we're missing the other part. And sometimes we call that the gap, or sometimes we call it the difference. And again, the tape diagram can help us to know, hey, we should subtract right now, right? Let's put it to use. In today's lesson, I'm not concerned with you doing lots and lots of problems. No, not at all. I'm concerned with how you organize your answer. And I really want to see some kind of a drawing. And whether you can choose a number bond or you can choose a tape, but something to make sense of the problem. Let's do one or two and I'll show you an example, right? That's why we do these tapes. 38 markers were in the bin. Chase added 43 markers that were on the floor to the bin. How many markers are in the bin now? Well, first of all, I don't usually use this word too often, but I am picturing something. Are you picturing something? You know, let's consider that the bin, right? And at least we can imagine when we see that. There's the bin. So how many were in the bin? 38. So let's do this, just like we talked about. We know 38 was one part, right? One part. So I'm going to put here 38 were in the bin. Chase added the 43 markers that were on the floor. Well, that to me seems like another part that he added. 43. How many markers are in the bin now? Well, we don't know. We don't know. That's the total. I'm going to put a question mark in there. That's what we're trying to find out. So, because we know that part plus part equals total, right? That gives us a clue. We can put these two together, right? We'll put them together. We need to make a number sentence like this. Let's put them together to find the total, right? Now, how do you do it? That's something that you ask yourself next. And there are different ways to do it. And you might pick one in your head right now. You might have a way that's different than the way I'm thinking about it, which is fine. It's totally fine. But the way I'm thinking about this one is, I'd love to make this. It's so close to 40. Couldn't we just turn that to 40? And if it's 40, then we can kind of mentally solve it, right? How many does 38 need to become 40? I'm thinking 2. So if I took this 43 and broke it apart into 2 parts, I can make it 2. And what would be the rest if I take the 2 out? The rest would be 41, right? So let's work with these parts. Instead of working with the 43, let's work with these 2 parts. We'll put these 2 together. That's the 40. And add the other part, 41. And mentally, once we do this, it's like, wow, I can do this in my head, right? 4 more 10s than 4 10s. Well, it's 8 10s and 1, right? 81. So, back to the question, how many markers are in the bin now? 81 markers. This is called a statement, right? Are in the bin. And this is what takes a correct and good answer into being an excellent. Gosh, yeah, do all the parts. Let's check and see how we did. R, D, W. Did we read it? Yep. We referred to it more than once even. Did we make a drawing? Well, what did we draw? A number bond, right? Even this bin is kind of a drawing just to help us imagine, but number bond really helped us. Did we write, that's what the W is for, a number sentence? You bet. Did we write a statement? We've got a complete answer. Looking good. Let's do another. There are 29 fewer big stickers on the sticker sheet than little stickers. You know, I feel like it's okay. Just want to picture this. That's a sticker sheet, right? And he's got big ones, right? And it's got little ones. I'm just trying to imagine this. There are 62 little stickers on the sheet. I think I want to draw this as a tape. Those 62, I know that. You know that, right? Let's draw it as a tape and label it 62. And what size are the 62? Little ones. Okay. Now, what else do we know? That there are 29 fewer. What does this word mean, fewer? If you're thinking it means less, well, good. That's what it means in this sentence. It means less. There are 29 less big stickers on the sticker sheet than little stickers. Well, what can I draw to show 29 less? If I draw tape, is it going to be less than this tape? Yeah, it's going to be less. 29 less. Okay? I'm going to draw it like that. So I'm not really sure how many big stickers there are, but I know one thing, that it's 29 less. I'm going to put the 29 here. That's 29 less. This group is 29 less than 60. And you know what that reminds me of? If I know something's 29 less, I know that is the big number, right? The 62 is what's going to be representing the total here. I know that I need to subtract 29 from 62. And that helps me to know that's the missing part. The big stickers, that's the missing part. Now, if you're thinking, wait a sec, I think I want to do that with adding because I know the big stickers plus the difference equals the little. You actually could. You could say, hey, 29 plus something, the missing part, is equal to 62. That would work, and that would work. In either case, we want to find how many big stickers there are, right? And that's our challenge right now. Well, once again, here we are. We made a nice drawing. We have a number sentence, and then there's the question of how. Let's I want to go with an arrow way here. I'm going to go with an arrow way using this one. If we go from 29 and we're counting on to 62, we'll find our answer with the arrow. So here we go. 29, arrow. What can we add to get close? Well, let's go tens at a time. 10 more than 29, 39. Let's go another 10. 10 more than 39, 49. I hope you're saying this with me. I hope it's coming to your brain like, boom, got it, right? 49, 10 more than 49, 59, right? Can we go 10 more? 10 more than 59 would be 69. Wait a second, we're trying to get to 62, right? We don't need to go another 10. Let's just go up to 60. That'll be easy. We'll go plus 1, get us to 60, and we're going to 62. How many more from 60 to 62? 2. Now we're not done yet. We got to put these little hops together, right? Because if we went all these little ways in the arrow, now we got to put them together. 10, 20, 30, 31, and 2 more than 31. 32, 33. 33. That's how far we went. I think we just solved it. I think we know how many big stickers there are, right? There are 33 big stickers. Okay. Did we make a drawing? Yes. 2 of them. Number bond and a tape. Did we have a number sentence? Yeah, actually 2 of them. Did we solve the problem? Yeah, I have a statement that answers it. You bet. This is the kind of thing I'd like you to do. Go slowly, go carefully, and please make drawings to match the problem. Have fun.